morning. It is Friday, May 22nd. Today I can determine congruence by using the three special angle rules. And the key to these rules is inscribed. I'm going to kind of develop the three rules for you. We're going to talk about them, and then we're going to kind of put them in action. So, let's make a circle. And let's start by making this a little bit bigger. Let's get my pen going on here. That's too big of a circle. I had a feeling that was going to happen. That's fine. So, let's say I draw this. And what type of angle is this when the vertex is on the circle? Well, we call that an inscribed angle. And an inscribed angle is half of the arc that it intercepts. So here is your intercepted arc. So let's say that this here is 60 degrees. If that's the case, then the inscribed angle is 30 degrees. Now, let's say I draw in another inscribed angle. Well, isn't this angle also intercepting this arc? Which means that it's also half of that arc, which means it's 30. So these two angles here are both inscribed angles intercepting the same arc. Because they're inscribed angles and they intercept the same arc, they must both be half of whatever the arc is, so they must both be congruent. So the rule is angles inscribed to the same arc are congruent. So I don't need the numbers in there, but if I have two angles that both intercept the same arc, inscribed angles that intercept the same arc, then they must be congruent. So that's your first special rule. All right, your second special rule. I'm going to draw in a diameter. And I'm going to draw in an inscribed angle. Well, a diameter, we said, cuts a circle in half, making this arc half of a circle, which is 180 degrees. So this angle intercepts this 180 degree arc. This angle intercepts a semicircle. And since an inscribed angle is half of the arc, half of 180 is 90, making this a right angle. An angle inscribed in a semicircle is a right angle. Since it intercepts a 180 degree arc, and inscribed angles are half of 180 is 90, an angle inscribed in a semicircle is a right angle. That's your second special rule, and the third one's very similar to that. We're going to again start with a diameter, and then I'm going to draw in a tangent. Now, this isn't technically an inscribed angle, but we treat it the same way. It's still an angle that's on the circle. If the vertex is on the circle, the rule holds true, the angle is half of the arc. So what's the intercepted arc? Well, this piece goes here. This piece leaves the circle here, so my intercepted arc is 180. And again, since it's half of that, it makes it a right angle. So this rule is a tangent and a diameter intersect to form a right angle. So those are your three special rules, and they all deal with inscribed angles. They all deal with angles that are on the circle. So the three of them are all listed here. And again, notice that they all have to do with angles where the vertex is on the circle. That's why we always want to look for inscribed angles. You always want to look for angles that are on the circle, and then it's all about the intercepted arc. If they intercept the same arc, they're congruent. If they intercept an arc of 180, then they're 90 degrees. So what kind of questions are we going to have based on this? We're going to skip number 1. Let's take a look at number 2. Blah, blah, blah. Which statement is not always true? So we're going to go through each choice and we're going to see if it's true. And it's all about the inscribed angles and it's all about the intercepted arc. So choice 1, angle ACB. ACB is this angle right here. It's inscribed. What arc does it intercept? Well, it intercepts AB. I'm going to get some different colors here. So if the other angle also intercepts AB, then they must be congruent. So the other angle is BCD. BCD is right here. This piece goes to B. This piece leaves at C. This one has BC as an intercepted arc. Are those arcs the same? No. Do I know that they're congruent? No. So I don't know that that one is true. Now I'm going to go to the next choice. ABC. ABC is inscribed to AC. Now what's special about AC? It's a diameter, it's a semicircle, which makes it a right angle. So I know that ABC has to be a right angle. If ACD is a right angle, then they must be the same. ACD is right here. Well, there's something special going on here. ACD is a tangent meeting a diameter, and we said when a tangent meets a diameter, it forms a right angle. So are those angles congruent? Yes, because they're both right angles. They're not inscribed to the same arc, but they're both inscribed to, they both intercept arcs of 180. They're both right angles. They're the same. Choice 3, BAC. BAC intercepts BC. DCB intercepts BC. They're both intercepting this arc of BC. That means they must be congruent because two angles that intercept the same arc are congruent. Choice 4, let's clear this. Let's do a new color. I get bored with these colors. CBA intercepts a semicircle, which makes it a right angle. AEC intercepts a semicircle, which makes it a right angle. They're both right angles, therefore they're congruent. Which statement is not always true? Choice 1. And I always go through all 4 choices regardless. If it's correct, I put a check. If it's incorrect, I put an X. I'll either end up with 3 checks and an X or 3 X's and a check, and then I'm going to read carefully and make sure I answer the question. So it's just utilizing these rules to get my answer. In the diagram below, blah, 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 Sam decides to apply this theorem to the diagram. An angle inscribed in a semicircle is a right angle. So it's talking about, let's just clear this so it's a little bit nicer. He's talking about this rule. So whichever angle represents that is going to be your answer. So let's go through the choices and see. Angle AOB. First of all, is angle AOB an inscribed angle? No, it's a central angle, so that can't be an angle inscribed in a semicircle as a right angle. BAC. BAC. Is BAC an inscribed angle? Yes. What's it inscribed to? What does it intercept? This piece goes to B. This piece goes to C. Is BC a semicircle? Is BC a diameter? Is it half of the circle? No. BD is the diameter. BC is not, which does not make it a right angle. DCB. DCB. It's inscribed. This piece goes to D. This piece goes to B. Is DB a semicircle? Is DB a diameter? Yes. Therefore, this must be a right angle. Yes, angle inscribed in a semicircle is a right angle. That one looks good. Again, I'm going to go through all four choices. Choice 4, FDB. FDB is right here. FDB. FDB is a diameter meeting a tangent. Well, when a diameter meets a tangent, it forms a right angle. So yes, it's a right angle, but is it an angle inscribed in a semicircle? No, it's a tangent meeting a diameter. So even though it is a right angle, it's not an angle inscribed in a semicircle, making it a right angle. Your answer is choice 3. This question is going to be a little annoying, but you'd have to look at them carefully, understand these 3 rules, and once you get the hang of it, you get the hang of it. Let's, why don't you try number 4 in your own right now. I'll give you a couple minutes. In fact, why don't you try 4 and 5? Okay. You can pause it if you need more time. Which statement is always true? EAR is inscribed to ER. RAB isn't inscribed, but it's on the circle that intercepts RA. Are those congruent? No. Are they the same arc? No. Choice 1 does not look good. Choice 2, REA. REA is inscribed to RA. SAE is a tangent and a diameter, making it a right angle. RA is not 180. They're not both right angles. That's not it. Choice 3, SAR intercepts, this piece goes to R, this piece leaves at A, intercepts AR. BAE is a tangent and a diameter, making it a right angle. Is the yellow a diameter? No, the yellow is more than a semicircle. It's not a right angle. That's not your answer. And ERA is inscribed to EA, which is a diameter, a semicircle, which makes it a right angle. BAE is a tangent and a diameter, which makes it a right angle. They're both right angles, therefore they're congruent. Choice 4 is your answer. Number 5, BUI, BRI. BUI is inscribed to BI. BRI is inscribed to BI. They're both inscribed to the same arc. That makes them congruent. Now, choice 2 tricks a lot of students. Let's see if you got tricked. ITR and BTU. These are not inscribed angles. They're not on the circle. These are not inscribed angles. We learned about these angles earlier in the year. These are vertical angles. And vertical angles are congruent. Not because they intercept the same arc, but because vertical angles are congruent. So understand these circles problems, you might also incorporate other rules. So they don't intercept the same arc, but they're not inscribed angles. So we're not even talking about that rule. They're vertical angles. Vertical angles are always congruent. So yes, those are congruent. UBT. This one is inscribed. It goes to U and it goes to R. So UR is the intercepted arc. BRI. This piece goes to B. This piece goes to I. So BI is the intercepted arc. Do they intercept the same arc? No, the yellow and the blue are not the same arc. Are they congruent? Do I know that BI and UR are the same? No. So I don't know that choice 3 is correct. And let's just go to choice 4. RBU intercepts RU. RIU intercepts RU. They both intercept the same arc. That makes them congruent, which is not true. Choice 3. That's it. So I think that's it. I'm going to go over number 9 with you. Number 9 is a little tricky. And then after that, you're going to practice. I'm giving you an extra day for this. And we're going to be utilizing these 3 special rules to do proofs next week. Both congruent triangle proofs and similar triangle proofs utilizing these rules. So let's just go over number 9, and then we're going to call it a day. Let's go yellow. I kind of like yellow. Yellow is becoming my new favorite. It's very bright. In the diagram below, BC is the diameter of circle A. Point D, which is unique from points B and C, is plotted on circle A. So it says there's a point D. It's not B. It's not C. So it doesn't say where it is. So I wouldn't put it somewhere special. Like I wouldn't put it in the middle of B and C because it doesn't say that it's in the middle. And it might look like certain things are true. So I'm just going to kind of put it at a random spot, not in the middle, just randomly on there. Which statement must always be true? BCD is a right triangle. BCD. Is that a right triangle? Well, it's inscribed to BC. BC is a diameter, semicircle, which makes that a right angle, which makes that a right triangle. Yes. Choice 1 is true. It must be a right triangle since D is inscribed to a semicircle. That is this rule right here. Let's go through the rest of the choices. Let's get D back up there. BCD is isosceles. BCD is isosceles. Looking at it, doesn't look isosceles. There's no reason to believe it's isosceles. It looks scalene. In fact, it's a right triangle, so the hypotenuse has to be bigger than the legs. The legs are not the same. No, there's no reason to believe it's isosceles. Now, if you drew D in the middle, let's say you drew D in the middle. If you drew D in the middle, then it might look like it's isosceles. Again, that's why I shouldn't draw it in the middle. I don't know that it's in the middle, so I want to draw it somewhere random so it doesn't appear to have properties that it actually doesn't have in reality. All right, choice 3, BAD and CBD are similar triangles. This is where it gets a little tricky. Again, we know what our answer is at this point, but I like you to go through all 4 choices, but it is going to get a little tricky at this point. BAD, BAD, and CBD are similar triangles. Well, in order for them to be similar triangles, they need to have 2 of the same angles. Angle is how I prove triangles are similar. They have 1 of the same angles. This is a reflexive property here, but I don't know that A and C are the same. The D's are not the same D. I don't know that they're similar. I don't have enough information to say angle. I have enough information to say they have 1 angle the same, but not 2. And then choice 4 is talking about 2 separate triangles, BAD. So this one again, and CAD. It says, yes, these are congruent. I mean, looking at them, it's pretty obvious that they're not congruent. And again, if you would have drawn D in the middle here, it might look like they are, which is why it's important, if it doesn't tell you where it is, to just try and draw it somewhere random. That way it won't appear to have properties it doesn't. Choice 1 is correct. Again, it's a right triangle because D is a right angle because it's inscribed to a semicircle. So, listen, this is not the easiest of lessons. I'm not going to claim that it's the easiest of lessons at all. But it's not, I mean, it's not super challenging. You have to just understand these 3 rules. They all have to do with inscribed angles on the circle. If you have 2 angles that are both inscribed to the same arc, I need a pen to write this. If you have 2 angles that are both inscribed to the same arc, then the angles are congruent. If you have a tangent meeting a diameter or a radius, the same would apply to a radius. The intercepted arc is 180, which makes the angle right. And if you have an angle inscribed to a semicircle or a diameter, then that's also a right angle. Your classwork / homework is to finish the worksheet. And your quiz, today's Friday. We don't have school on Monday, so I'm going to say your quiz, actually I'm going to give you an extra day. So today's Friday. Tuesday you will have to practice this as well, so the quiz will be due on Wednesday. I would not wait till Wednesday, I would just get it done now when you're doing this lesson, but it will be due on Wednesday, and on Wednesday we will do proofs utilizing these rules. 2 days on Wednesday and Thursday for congruent, 2 days on Friday and the following Monday for similar. And we're getting really close to finishing new material. Any questions, reach out to me and remind. Stay safe. Have a great holiday weekend. Do not assume that everything's okay because everything's opening back up, and go out there and party and hang out with your friends and get close to them. We are still very, very much at risk. Make smart, responsible choices. Understand that you getting together with your friends means you can catch this thing, you can spread it to your family, and bad things will come from that. All right, be cautious, be smart. Any questions, let me know.